So here are some examples of things I don't want you to be doing. Now, in visualization, bad visualizations of data are called data ducks. They're things that people use and they're often unhelpful because they completely confuse the poor people who are trying to read them. Now, one of them is the pie chart. If you've got more than a few slices in your pie, then really don't use them. It's very difficult for people to visualize and to calculate angles within pie charts and to be able to extract the numbers from them. Having your data as a bar chart is a lot easier to understand because you just slide your eye across the data. Another thing that's particularly annoying are 3D plots. They look good, they look interesting, they've got all sorts of drop shadows and exciting ray tracing and surfaces and textures and great things. But are they helping your data? Are they making it clearer? If they're not, don't use them. And to be honest, I consider it Excel's worst crime to statistics. So let's have a little look at some of these ones. Now, this is the original pie chart, which was Nightingale's Rose. So Florence Nightingale used this to demonstrate that most of the mortalities during the Crimean War were from disease rather than wounds. So here, if you look at the number of deaths in each of those particular months, you can see that the disease, the red segment, is a lot bigger than those who are dying of other or of wounds, which is the blue segment. In fact, sometimes the blue segment is practically non-existent. Now, here is a slide where somebody's looking at the age structure of college enrolment. This is taken from Tufts' textbook, where he suggests this is probably the worst graphic that he's ever seen. So what you have here is the use of red and blue just to make something three-dimensional, and also yellow and green. You've got two truncations on the graph. So you've got truncation to take it up to 28% and a truncation between 30% and 60%. You've got a continuous smooth line connecting these particular years when they're discrete categories. There's no reason why you should do it discrete. It is the percentage of students who are under 25 and those that are over 25. So always should add up to 100%. So this is an ideal thing for a stacked bar chart. So this is a stacked column chart showing exactly the same set of data. You've got the over 25s in the brown colour, the under 25s and unders in the blue colour. This shows you that practically there's no difference between any of the years and there's nothing particularly happening. Whereas when you look at the other chart in the 3 dimensions, you quite frankly have no idea what's going on at all. Now this wins a prize, which is why it's got the scream at the top of it, as to what on earth this is supposed to show. So what I had done was ask students what their favourite colour is, and then I tried to put it in a bar chart using Excel. So Excel decided that I had too many wedges for the main pie chart, and so it took one of those wedges and then divided it into a sub pie chart. This just makes no sense whatsoever. I have no idea about the relative size and angles in the subgroup pie chart compared to the main pie chart. It is unintelligible and impossible for me to understand. Meanwhile, I could have done it in this 3D projection of a bar chart where I'm using cylinders. But can you read any of those heights? To read those heights, I'm going to have to rotate the cylinders around until they're flat, so I'm looking at them from the side. But if I'm doing that, I lose all of the 3D properties, so I might as well just have drawn a plain 2D bar chart. So I would suggest draw a plain 2D bar chart. Now this is my pet hate, though you will be asked to do this innumerable times, and you will see it in science, you will see it in Nature, the BMJ, and everywhere else. This is when you have something where you're trying to represent the average, and you represent it as a bar chart. This is meaningless. The only point that makes any particular significance, the thing you need to read off these charts, is the top of each of those bars. The coloured in section has no meaning whatsoever. What you need is a circular point at the top of each one of those bars telling you where the mean value is. Then you need their error bars. But the colouring in of those particular bars within this bar chart has no meaning. Bars should only be used for counting data. Then the area that you colour in represents the frequency and the number of counts of a category. Then a bar chart is serving as a bar chart. Here, a bar chart is not providing any useful information whatsoever.